Hello, I am John deGrosbois, and I am presenting to you our work, The Predictive Perception of Dynamic Vibrotactile Stimuli Applied to the Fingertip. My co-authors are Massimiliano de Luca and Raymond King from Facebook Reality Labs, and Mounia Ziat from Bentley University. Here, we investigated how to best simulate tactile features within a vibrating touch-based display. Lim et al. Reported that a region of relatively higher frequency vibrotactile stimulation tends to feel physically higher than an adjacent lower frequency region. Given that these stimuli were presented at suprathreshold levels, a variety of mechanoreceptor populations were invariably active. We therefore hypothesized that providing a dynamic pattern of stimulation would further facilitate perception of such details as edges and corners. To test this hypothesis, we provided vibrotactile stimulation to the fingertip using a custom pin array. Notably, two pairs of frequencies were spatially arranged across the pins such that the higher frequency could be presented to the left or to the right. Critically, we varied the pattern of stimulation within a trial by gradually inverting the frequency pairs. These shift durations ranged from 0 to 1100 milliseconds in a 2000 millisecond trial. At the end of each trial, participants were asked to report which of three possible shapes they had experienced. Here, we have presented the average relative response rates across all conditions. We observed a significant response choice by initial state interaction. That is, participants showed a stronger bias toward Shape 1 responses for conditions with a Shape 1 initial state. To further quantify this relationship, we next evaluated initial state response accuracy. This secondary analysis resulted in a significant interaction between frequency pair and shift duration. Post-hoc analysis revealed a single significant difference which showed enhanced accuracy for the 10 and 158 Hz frequency pair at a shift duration of 500 milliseconds. Overall, we found that dynamic stimulation patterns do lead to more robust perceptions of simulated vibrotactile features. Responses were consistent with a predictive perceptual code in that the initial state was more likely to be reported than the final state. When quantified via the initial state, response accuracy was maximized for the larger difference frequency pair at a shift duration of 500 milliseconds. This may indicate that performance can be improved if dynamic vibrotactile stimulation is provided at timescales consistent with naturalistic exploratory movements. Thank you for your time, and please feel free to email me with any questions.